So, I've asked you guys to follow me on Instagram. Do it right now. I'm just kidding, you don't have to. But if you have been following on Insta, then you probably saw this post back in July, showing my design for what could likely be the most sophisticated web shooter design yet. I'm talking about design with intent. Now, obviously, I'm inspired by fiction, motivated by fiction, as I'm sure many of you are. There's something about the way engineering is portrayed in fiction that I've always found a bit off.
Get me the promochloroparazine.
For what?
It begins catalyzation when the vapor hits the bloodstream.
You'll often see a brilliant invention come about as a result of just messing around. Don't get me wrong, messing around is pretty important. It's pretty much all I've done for years now. It's a vital part of the creative process, and countless priceless ideas have been born from it. So please don't take what I'm about to say as a call to stop messing around. As an idol of mine once said,
The only difference between science and screwing around is writing it down.
But the most important question here is why? Why do we write it down? It's not just so we can show it off, it's so that we and others can learn from mistakes. Learning from mistakes saves time and money, and that is a very powerful thing. In a lot of TV and movies, you'll see an engineer take a little bit of this and a little bit of that. Oh no, it doesn't work, just hit it with a hammer. Oh my god, what do you know? He's a genius.
The data just doesn't justify this test.
Of course, in the real world, it doesn't work that way, as much as we'd like it to. No, in the real world, we can make predictions based solely on observations, and especially mistakes that other people have made. These observations have led to the mathematical laws I presented on my channel before, which have been built up over centuries as extremely useful tools by experimentation, leading to even more observations. And the result of this is we don't have to rely solely on trial and error, which is an undeniably expensive approach. Instead, we can make predictions on how our designs will function before they're even built. So if you're thinking about designing something new, my advice is sit with it for a little while. Make some serious predictions, challenge your own hopes for the design, do some modeling. If you do this, time and money will be on your side. This is the approach I took with this design. I thought, what can I do with current fluid web shooter technology that makes a unique and practical web shooter? I want concealability, I want performance, I want changeability. Concealability definitely means the web shooter had to be small, and with my new research into the effect that common viscous fluid laws have on web shooter performance, I was able to consider the optimized valve geometry I presented in my last video. I designed a valve with this exact geometry as part of a push toward product development for dragline dynamics. If you don't know what that is, just please watch any number of my videos from the last few months. But the prototyping costs were too high, so I figure making a smaller version of this was the perfect chance to accomplish concealability and cut down on material costs. I assumed the scaling law for viscous fluids to be the Hagen-Poiseuille law. That is, I hypothesized that I can make this valve perform similarly while decreasing the size. Decreasing the radius hinders the flow, but decreasing the length helps the flow. A similar flow with the same pressure drop and fluid properties means that the ratio between the fourth power of the radius and the length must remain the same. So whatever factor by which we scale the radius down, we must scale the length down by the fourth power of that factor. This scaling gave me a new valve, which is simultaneously small, but theoretically does not sacrifice performance. Concealability also requires that people aren't asking why you're wearing an unmarked hunk of metal on your wrist. So I figured, why not make this web shooter a watch that actually tells time? I find it funny that this is the opposite of what was done in 2012's The Amazing Spider-Man. But then of course, if it's a watch, watches don't have long tubes coming off of them like I have with my web shooters, which I have of course so that I can hold more material without increasing the moment of inertia of my arm super dramatically. But the tube also theoretically would worsen the performance of the web shooter, as the fully developed flow in the tube induces a pressure drop, so the drop across the nozzle is not as dramatic. So I could get rid of the tube and have a fluid reservoir in the watch. This is something I've never done. I've always had some sort of canister external to the main unit. Having the fluid reservoir lead directly into the valve will significantly reduce the pressure drop that occurs before the valve, dramatically increasing the pressure drop that occurs across the valve, which increases exit velocity. But of course, the watch unit itself will not be able to hold a lot of fluid, and that makes the whole thing sort of pointless. But I found the solution, something I've always been looking for. The ability to have plug-and-play web fluid cartridges. I'm talking about the classic, shoot, I'm out of web fluid, better put another cartridge in, and it takes 5 seconds. Just plug it on in there. And these cartridges can be anything you want, as long as you have the correct adapter, just like an HDMI cable. I've attached my old ARM canister and tube to this adapter, and it works great. Both sides of this quick connect are automatically shut off upon disconnection, and that means only a small amount of fluid is lost during cartridge switching, and the web shooter can function whether or not the cartridge is connected. So there's my design. It's time for manufacturing. Now, as I alluded to earlier, I'm very interested in product development for you guys, and this web shooter is a great candidate, easy to use and concealable. But this is far off. This project is currently just in the prototyping stage. Shapeways is a 3D printing service that allows users to open up a shop and sell their designs through the website, so I figured this may be a good way to get started. So I paid a lot of money to get all of the necessary parts made by them and a variety of their materials and processes, just to see if their manufacturing was up to the task. So basically, I just got this in the mail, the valve stem for the design, and I got it made in aluminum. And so as you can see, the quality is not great, which, you know, is okay. Like, they usually probably don't get parts that need to be this small and intricate. Whether or not it will work, I can't say for sure. I can confirm that the necessary geometry is here. It's just not great. If I put a little piece of plastic here through the nozzle, you can see it comes out where it should. So there's definitely a cavity in there, as there should be. The back is probably the roughest part, so I was just polishing it. The O-ring slots are a little wonky as well, but all the features that should be there are there. It's just a matter of, will it work? Nothing really needs to slide against this because there will just be O-rings around here. But of course it is kind of crucial that the O-ring slots are circular. If they're not, it won't seal super well, so we'll just have to see. Alright, so I just did some polishing with my Dremel tools. I'm a lot happier with this result than I am with what I got straight from the company. So even though they won't polish aluminum where you can still do it yourself, you can see it's still a little bit rough, but it should be alright for my purposes. I can't really seem to get it any better than this. I await the rest of the parts, and as soon as those get here, I'm gonna assemble the web shooter. It's gonna be really exciting. I just got this in the mail. It is the rest of the parts for the web shooter from Shapeways. Let's take a look at what's inside. Okay, so we got a part here. That's the valve housing. So we got one part of the nozzle head, another part of the nozzle head, and then this looks like the steel parts. It's very heavy. We'll talk about the weight in a second. And then it's just some bubble wrap. So you can see I've also already put the O-ring on the bottom here that's supposed to seal with the nozzle housing. So it should be interesting to see how these parts fit together. So I ordered the hand polishing, and this is steel. So I believe this is silver steel with bronze. So it's pretty heavy. I would ideally get this in aluminum, but it's not polishable. Brass is actually even heavier. This was actually the cheapest option to do it in steel. Since I'm doing a prototype, I want it to be as cheap as possible. It was still pretty expensive, so go support me on Patreon. Looks like it's actually hollow. So that's actually a chamber in there for the web fluid to be stored. So the big question here is, does the fitting that's required for the web shooter fit into this? The fitting should hold just up to 100 psi, which is pretty much right over what we need. Maybe? No, it's crooked. Interesting, okay. So it's not the best with thread detail. I do want to point out that this is FDM 3D printed. This fits the fitting just fine without any sort of finishing. So yeah, it seems that, you know, your average FDM plastic PLA 3D printer can make better threads than this metal 3D printing technology that they use. Okay, so I just got back from the shop. I have threaded this part just a little bit more. It fits pretty well now. Let's see here. Yeah. So, yeah, that can be tightened with a wrench, but there it is. So that's that quick connect. Boom, cartridge, and then boom, no more cartridge. When I was at the shop, I figured I would also tap these two holes, which are supposed to be M3s. I don't know, like it's either that the threads aren't even there or that it's just not gonna happen with these guys. That's a little bit disappointing, and I won't be able to see it function today just because of that. So also while I was at the shop, I decided to file this hole a little bit. That's where the valve goes. It's a little rough in there, so I wasn't sure if the valve housing will fit. Seems like I smoothed it out a little bit, so let's check on that. So for the valve housing, I got it in polished brass. Let's see. So they give you a nice little bag for the polished brass, because I guess usually people make jewelry with it, which is kind of nice. Oh my gosh, look at this. Look at this. That's beautiful. Look at that finish. They polish it for you and everything. So it looks like this manufacturing process is supposedly wax casting, and that's very accurate, surprisingly. So let's see if it fits in here. Oh, it does. Okay, look at that. That fits very nicely. Incredible. Okay, cool. So the next piece that we need to look at is another steel piece that I also got polished, and that's this one. And you can see it looks like they printed it like this, because you can see the contour of the layers, making some lines here going up and down like that. But it's not too bad. Polishing definitely does it justice, especially on this side and on this side, they're flat. There's a little bit of a burr there, so they didn't deburr it entirely, which is not super great. Okay, so the valve housing brings us to the valve itself, which is sort of a sub-assembly. There are 3 O-rings supposed to go around the valve stem. These 2 are for sliding seals. That's to keep stuff from leaking out when open. And this is the sealing O-ring for the closed position. Okay, first one fits pretty well. Next O-ring fits pretty well too. Then the real question is how they seal against this brass. This is pretty smooth. They polish it. It actually looks really nice on the inside, but it doesn't really matter. Oh, actually, it fits, I think. Looks like it fits. So the friction between the rubber and the brass does make it a little bit tough to open, but it seems like it works, and yeah, those 2 O-rings are still right where they're supposed to be, so they didn't pop out.
So the Shapeways products are pretty much all good, except for the main body/pressure chamber. I had this part made of steel, and aside from the obvious oxidation that was taking place after I exposed it to water, which does not bode well for its interaction with web fluid, the problem was the M3 threads to hold the front plate on. I couldn't cut them. The material seemed to be extremely strong. This part was a waste. I still had to make a prototype, so I made plans for a manually machinable version of the part, and this time I'd use aluminum. Beautiful, beautiful, beautiful aluminum. This means the part won't oxidize, and I can ensure it has the correct threads. Sadly, machining requires that parts not be hollow, meaning I have to make a pressure chamber in 2 parts, the body and the lid. Eventually, 3D printing the body with metal processes would be a great advantage, as it would allow some size to be chopped off the top. After adding some hardware for the watch and designing a removable trigger system, we had our web shooter. The aluminum valve stem seemed to have some problems at first, so I reprinted the shape in clear SLA resin. I actually went through a ton of iterations with that, so I won't get into it. Basically, the problem turned out to be the main O-ring being blasted out of place by the flow, so the aluminum valve actually probably would have been fine. But the SLA technology is so much more accurate than the selective laser melting used for the aluminum, so I stuck with it. Of course, the advantage of the aluminum is it's generally more chemically compatible than plastics, so it opens the door for more types of web fluids. Now remember, this end result is just a prototype, but it already works quite well. High exit velocity, small body, configurable fluid containers, it only gets better from here. Let's do a final teardown of the device.
Alright, so here we are with the little tiny watch web shooter unit. Now, as you can see, it tells the time. The cartridge that I made looks like this. Gave it this nice orange appearance, for my color scheme. I don't really have a robust test for these yet. So the cartridge fits in just like this. No problem. And you can remove it just like this. And I've actually just cleaned it out with a cleaning fluid. So it's getting ready to be filled with new web fluid for future new fluid tests that I'm planning, so stay tuned for that. So as you can see, we have a foldable trigger. It's pretty easy, classic trigger design, as the trigger wasn't really the main task for this project. And the cool thing about this trigger is that you can easily just twist and remove it, and you're back to just a really disguisable watch design. All right, so the first thing that needs to be taken off is this 3D printed cover here. Almost not recognizable as 3D printed. Because it looks sort of like painted metal to the untrained eye and from far away. I've had many questions about this watch, and people are just like, wow, that's what kind of watch is that? And I say, it's a Kamanki. It's a cheap watch face I got on eBay. We can remove the screws attaching this part, and you can see that only serves as, first of all, the base for the trigger, and also for holding the watch on. This part also serves a little purpose out in the front of the web shooter here. You can see that it reaches all the way underneath the front plate, and I did that to sort of add it as a sort of spacer here to relieve some of the pressure. So there's 4 screws attaching that to the top of the web shooter, and we should be good to open it up, and it should be fairly clean. You can take the front plate off. Now that's attached with these 2 screws here. These are M3s. So this is a crucial load-bearing component. This is not aesthetic. These screws attach this front plate to the front, and then we have our valve. So this is the valve. It's freaking tiny. It looks like it's held up pretty well, nicely sealed. And we can do an actuation of it. Yeah, so that's how it operates. That's the valve right there. This valve has a miniaturized version of the optimized geometry that I presented in my fluid dynamics video that I discovered. Where that sits, we have an O-ring that seals against. So the O-ring sits right here on this lip, and the valve sits against that, like so. And then the front plate sits over that and presses it in with those 2 screws. And that is how we get our seal to attach the valve. So it's pretty cool. Let's pop this off real quick now that we can do that. All right, so there's the watch part, and the rest is just, this is the web shooter right here. An aluminum body, I machined it myself. We'll get to that in a second. Here is the watch
face. So this just pops out. You have the 3D printed part, and you have the watch face. I cut the wristband holders off of this watch face, and this is one of the thinnest watch faces I could find. Did we go an hour back or an hour forward? So it's a surprisingly clean operation to rip this apart and put it back together again, considering the mess that this device is supposed to create. Now this is another crucial pressure component. Remove these screws, and this creates the lid, or the roof part of our pressure vessel. Alright, and then, it's sort of stuck on there, so let's just, there we go. Oof. Okay, so, an aluminum part here. Machined this as part of the same operation that the main body was machined. It's about 1/8 of an inch thick. You might be able to make it even thinner, but I don't really try my luck. This seemed like a solid part. 1/8 inch thick aluminum is usually structurally sound. The next part is this rubber seal, which fits really nicely. We were able to get a good seal. Looks like it permanently deformed, but you'll probably still be able to use this as a seal, because it was working just fine before. This is the inside of the web shooter. So you can see I wasn't lying. There's a whole ass fluid reservoir in here. And so if you compare that to these cartridges, I calculated this to be about 1/3 of an ounce, 1/3 of a fluid ounce. And in here is supposed to be 1 ounce. So this holds about 1/3 of this. So when you attach them together, you get to about 4/3 of an ounce right here. So yeah, that's pretty cool. So yeah, this is the quick connect part that interfaces with the cartridge, just like this. This is the machine part on its own. I guess not on its own. Watch band. I want to replace this with a different sort of watch band anyway, very soon. So we'll set that aside. So I machined this on a manual mill, as I machined this on a manual mill. So these parts were manufactured by me, and I almost forgot we have to break down the valve itself. So you can see this is a tiny valve, and it works fantastically. The inner diameter here should be less than 1 millimeter, but we still have a large exit velocity, and that is due to the other improvements in the performance. So you might be able to widen this diameter a little bit. I'm not sure exactly what that would do, if that would help or hinder it. But yeah, so this is the part that the trigger presses onto to actuate the valve. And then we have the spring. The spring remains outside the web fluid, so that dramatically reduces the mess that repairing web shooters has created in the past. And then we end up with our valve stem right here. And you can see there's some material blockage here, so it's good that I open this up so I can start to clear that away. And that should hope it perform better, but it was doing fine before I opened it up. So now it'll do even better. So the only parts that were made by Shapeways that I'm using are this part and this part. So that's the valve body and the front plate. The valve body had a really nice finish to start. Finish is kind of diminished since I've had it. It's been through a lot, but it's a really nice part still, and it's super accurate. The valve stem fits like a glove in the middle. It's perfect. This front plate was made with steel, and as you can see, it's sort of yellowed over time as it's oxidized. But yeah, so Shapeways parts, these ones work very well. The body didn't work. Let me show you. The original body is right here. I still have it. I drilled a hole straight through in frustration, so this definitely wouldn't work anymore when I was trying to cut the threads where they were supposed to be in order to hold the front plate on. So initially you can see like that's supposed to go there. Instead I machined this, and that goes right there, and it works just as well, if not better. And the weight difference between these two is really striking, because this is steel, this is aluminum, and aluminum looks way better too, and this oxidizes. It's really disgusting. But I paid $60 for this, so please support me on Patreon. All right, so the valve stem is really small, as you can see. And there's 3 O-rings. This is from the Human Spiders design, to have 2 O-rings sealing against the wall of the valve body, like so, and 1 O-ring that seals in the closed position, but does not seal in the open position, just like that. And I can't take those O-rings off because I've cemented them on there with cyanoacrylate glue. As I mentioned before, they were popping out, which was causing the initial problem. So it could be that the aluminum valve stem would work fine, but this worked great, so I didn't. But it broke, right? Out of the 4 parts that I ordered from Shapeways, the valve body, the pressure chamber, the valve stem, and the front plate, only 2 were up to snuff for the final design, the front plate and the valve body. And then I had to make a pressure chamber or fluid chamber myself out of aluminum on a manual mill. That took a very long time. It was about 12 hours of labor total. I'm really, really, really proud of the result. I'm not really a machining aficionado, but I wrote out a plan to create this super complex shape without a CNC, and it worked really, really well. We have another part that I made, which is a watch holder. I think I'm going to modify this such that it doesn't stretch down here. That's kind of unnecessary. I also cut out this rubber piece to serve as the seal between the body and the lid. And then finally, I made the valve stem out of SLA clear resin, in addition to this small 3D printed valve face that interacts with the trigger. I also, of course, made the trigger. And then we have all of our commercial off-the-shelf parts, which include wash band and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 fasteners. Just 10 fasteners. 2 O-rings to seal the valve body against the web shooter pressure chamber. 1 quick connect fitting, 1 spring, 1 watch face, and that's it. It's actually relatively simple device, but the beauty of it is in that I designed with intent. I used scientific methods to predict how it would perform, and it performs great. So I hope you'll support more projects like this. There's obviously a lot more where that came from. Support me on Patreon at patreon.com/theamazing. Follow me on Instagram at the.amazing.labs. Check out my Spreadshirt shop on my channel. Thank you guys for watching, and I'll see you guys in the next one. Stay amazing.